Okay, so 1.2, we're going to have three main things we're going to learn today. Linear and nonlinear functions. We're going to interpret intercepts, x and y. And then we're going to learn about point symmetry and line symmetry and determine whether functions are odd, even, or neither. So the first part of this should be review for you. Hey, when you are working with a linear function, it's not raised to a power other than 1. So you'll usually see x, right? X to the first power with that. Okay, and the graph is a straight line. Now, a straight line can go up from top to bottom if there's a positive slope, can go down from top to bottom if the slope is negative. You can have a horizontal line or a vertical line, right? Zero slope, undefined slope. And then you have two main forms of the linear function. So the first form is y equals mx plus b. That is probably what you are most familiar with. This year we're going to be using what's called function notation a lot. And that's where instead of y, you have f of x equals instead of y. But it's still the mx plus b form. Again, this is called function notation. Okay, and then the last form is ax plus by equals c. Do you guys remember what that notation is called? What form? No? But that is one that you talked about. It's standard form. Okay, so you guys use that a lot when you're finding intercepts. But yeah, point slope form is one too. That's that y minus y1 equals n x minus x1. Okay. All right, and then this year we will talk more about nonlinear functions. This is going to include points that cannot all lie on the same line. Okay, and by that they do mean a straight line. You're going to have curves in there. It also cannot be written in the form y equals mx plus b. Examples of that would be a quadratic function and a cubic function. Okay, so a quadratic function would be f of x equals x squared. We can see the power here isn't 1 like it would be for linear. Do you guys remember what the shape is of x squared? Yep, so it's a parabola. It's either an upside down U or right side up, just depending on what it is, if you have a positive or negative leading coefficient. And then cubic, we've actually seen one of the cubic graphs this year. It's a line that has this slight bend in it. Okay, so for our first example, we just have to determine whether it is linear, determine whether it's a linear function. And then here it says justify your answer. So justify just means give a reason. Okay, and I'm going to help you with those reasons. Okay, and we're going to use this list to help us as well. So y equals 1/2 x. Is that going to be linear, yes or no? Yes. Okay, so one justification you could give is yes. And you could say it's in the form y equals mx plus b. The intercept would be 0. Yep. 0, 0. You can come back in the class. You kick yourself out, no, put yourself back in. Okay, and then for number 2, is this a yes or a no? Is this linear or not linear? So for this one, see how you have x squared? Okay, so x squared is going to fall in the nonlinear. Okay, so we're going to say no, because the exponent, you can say is 2, not 1. You could say no, because the exponent is not 1. You could just say that as well. Okay, I'd even be fine if you said no, it's a quadratic function. That would be fine. All right, and then for number 3, this isn't written in the form y equals mx plus b. It's not quite written in standard form either, but you could rewrite it. You could rewrite it as y equals negative 8x plus 5. It's okay to switch the order. Okay, so the answer for this would be yes, and you can say it can be written in the form. Y equals mx plus b. So yes, it can be written in the form y equals mx plus b. Okay. Now this one, there's a few different ways you could do that. Some of you might notice that that's in standard form, and I'm fine if you say yes, it's written in the standard form for a linear equation. You can also rewrite it so it's in the form y equals mx plus b. I'm going to remind you how to do that today because that is something we'll talk about tomorrow. So you can move over the 3x across the equal sign. When you drop this down, just make sure you put that negative with it. And then to undo a negative, what should I do to both sides? Yeah, you can either multiply by -1 or you can divide. So whichever one you like better. When you divide by a -1, it's going to change the signs. Okay, and then I am okay with you writing shorthand. So if you just want to write yes, and then the y equals mx plus b form, that's enough for me for that. Okay. Same thing with the other ones where we did the form y equals mx plus b. Because this work, I feel like, is speaking for itself there. Okay. All right, so for example 2, it just says determine whether the graph represents a linear or non-linear function. Okay, so you're either going to write linear or non-linear. Okay, and I think we could do that in 15 seconds or less. Ready? Okay, write it down if you haven't already. All right, Bella, will you tell me what you got for 5? Linear. Great, linear is correct. For number 6, Addison, what'd you get for that? Yep, so if it has a curve in it, it'll be nonlinear. Anytime there's a curve or a break, it will be nonlinear. Okay, and then Will R for 7, what'd you get for that? Great. Okay, so you do have your curve, and then 8, Cody, what'd you get for that? Linear. Great. Okay, and if it's linear, it's going to look like anything that we put up here, right? Positive, negative, horizontal, or vertical. All right, nice one. Now, in these notes, I put skip for example 3 so that all of your examples would line up with your textbook. So that's just for you guys to understand why I'm doing that. All right, so intercepts. We should remember that intercepts are going to intersect an axis. So if you are looking for an x-intercept, that's an x-coordinate where the y value is what? What's the y value for an x-intercept? 0. Okay, so it's the x-coordinate of a point where the graph crosses the y-axis. Okay, the x-axis, and the y value is 0. So when you're writing it as a point, you have your x value, comma 0. And then for the y-axis, the x value is 0. So it's 0, comma, whatever your y-intercept is. Okay, and then we're going to use the graph to estimate the x and the y-intercepts. I want you to do number 11, and then we're going to talk about 12 together. So if you've already done number 11, if you want to look at 12, 13, 14, start thinking about those, you can. And then when you are writing these out, make sure you're labeling which is which. So for the x-intercept and the y-intercept, for x-intercept, you can either write it as 12 or you can write it as 12, 0. Just make sure you label which is which. And then your y-intercept is -12, which is 0, -12. Okay, now some of you are going to naturally do this for number 12. And if you look at number 11, you have the numbers there. You have the scale. Same thing for 14, but 12 and 13, there's no scale. Whenever there's no scale given, that means they're going by 1 unit. Okay, and I think most of us just naturally assume that if we don't see anything, okay, that is the scale you're going to use if there's nothing labeled. Okay, now they're not always going to be whole numbers. So if you look at the x-intercept here, it is not exactly at the -1 part. Okay, so that looks about 3/4 of the way. So I'm going to estimate that that x-intercept is -0.75, or you can write -3/4. Okay, something like that is going to be an approximation. So if you put like -0.8 or -0.7, that's not something that I'm going to mark incorrect. You just want to be around that value. But for the y, I feel like that one is clearer. Okay, that's halfway in between -1 and -2. So your y-intercept is going to be -1.5. Okay, and again, if you want to write that as a point, that is fine. Just make sure that you're labeling those. Okay, and then will you guys give 13 and 14 a try? Okay, 13 is special because a point on that graph is 0, 0. So if your point is 0, 0 here, that means your x-intercept is 0 and the y-intercept is 0, which I can see many of you put that. That's great. There can. So, and it is common to have more than one x-intercept when you have a nonlinear function, specifically a quadratic function. So if you look at this graph, there's more than one x-intercept. There's more than one place it crosses the axis. So this should be -3 and -1. Sometimes I make my ands like this. You can make yours however you want, or you can put a comma. Okay, so -3 and -1. Okay, and then your y-intercept, okay, crosses here. This one can be a little tricky. It's not at 2. That line is right next to it. So your y-intercept should be 3. All right, for example 6, we're going to be doing some explanations. So I want you to make sure you wait for me with those. I want to make sure you have everything that we'll be looking for in this section. So Juan got a gift card for his birthday for the weekly online video game subscription. And the funds remaining on his card after each week are shown in the table here. So it says X is the number of weeks and Y is the amount of funds available. So that is on his gift card. Okay, so the first thing we're going to do are find the X and the Y intercepts. Okay, so I want you to look in the table and see if you can find those. There's a little trick to it. We'll talk about it in a second, but I want you to think about it first. Okay, so we just talked about the definition for the x-intercept and the y-intercept, right? And for the x-intercept, what do we know the value of y is? 0. Okay, so your x-intercept is what number? 5. Okay, so your x-intercept is 5. And you can see that in your chart right here. Okay, for the y-intercept, we're going to find where x is 0. And then when we are saying what these represent, the key here is we're going to be looking for units and then the context of this problem. Okay, so we know that the x-intercept is 5, and your y value for that is going to be 0. That's the amount of funds. So one way you could write this is you can say the number of weeks it takes, and then we're just going to identify that that's 5. For one to reach a balance of $0 on his gift card. Okay, so the number of weeks it takes, 5, for Juan to reach a balance of $0 on his gift card. Okay, this is not the only way that you can word it, but the key things we're going to be looking for are the units and then how many units there are. So somewhere in there it should mention the number of weeks and that is 5, and that the balance is going to be $0 on this gift card. For the y-intercept, okay, which is 0.50, one way that you can say 0 weeks is you can say the initial value. So we're going to say the initial amount on the gift card is $0. Oh, sorry. The initial amount on the gift card is not 0. What is it? Thank you, $50. Okay, so the initial amount does imply that it's the 0 weeks. That is fine. Okay, you can also say when no time has passed, there are $50 in available funds. That would be fine as well. Okay, or when Juan receives the gift card, there's $50 on it. Okay, any of those are fine, just as long as you are identifying the units. So I'm just going to put a little reminder here that says include the units. Okay, the reason why I put like little hints on here, because I know it's his first year with me, I include a little hint. That's usually something that you're going to be assessed on a quiz or a test. Okay, so on your first quiz or test, we'll have a problem like this, and points will be awarded for including the units. Okay, so you have to make sure you're saying the weeks and the amount in dollars. Okay. All right, so for 16, a rocket is launched into the air. The table shows the height y of the rocket after x seconds since it's launched. So I want you to go ahead and just write down what the x-intercept and the y-intercept are. And then I want you to start thinking about how you would word your explanation for the representation of each of those. Okay, so we should be identifying in our chart where your x value is 0, where your y value is 0. Okay, so for the x-intercept, okay, you should have 6. For your y-intercept, you should have 24. What's that? No, let's talk about what is happening. So if the height's at 0 feet, where is the rocket?
Not there.
It's on the ground, right? Okay, because it's going to launch and then it's going to come back down, right? Because of gravity. Yeah, your rocket, the rocket launch.
So we're going to use a suicide mission?
No, you always, whenever you throw something up in the air, what goes up must come down. Isaac Newton, physics.
It doesn't happen in 6 seconds, I'll tell you that.
It could. Yeah, it's not a, yeah.
Like a launch rocket? Like
yeah, it's common in physics to like make little rockets and do a launcher. I actually remember it in there. No, but you can do it in physics.
I don't have that.
Okay, so one way that you could word this, the x-intercept is 6. That means it takes 6 seconds. And there's a few different ways you can word this. I would say it takes 6 seconds for the rocket to reach the ground. You could say it takes 6 seconds for the height to be 0 feet. That would be fine. Okay, both of those are great. All right, and then for the y-intercept, we can use the initial height again. So the initial height of the rocket, and then we're going to include the unit. So we're not just going to say is 24. What does 24 represent? What's our units for that? The feet. And you can abbreviate that as well. Okay, so you can say the initial height of the rocket is 24 feet, or you could also say at 0 seconds, the rocket is 24 feet in height. That's perfectly fine. Okay, we just want to make sure we're using these in the proper context. All right. The next thing we're going to talk about is something that you have at least briefly seen in geometry. This is called line symmetry and point symmetry. So a graph is going to have a line symmetry if it can be reflected. Okay, a graph has a line symmetry that can be reflected in a vertical line so that each half of the graph maps exactly to the other half. That means if you fold it over, it's the same. Okay, it's the same on both sides. And the line that divides it is called the line of symmetry. Okay, nod your head if that's something you remember doing last year or in geometry whenever you did it. Okay, the next thing we're going to talk about is point symmetry. So point symmetry is when a figure is rotated 180 degrees about a point and it maps onto itself. So your book from last year may have called this rotational symmetry, or they may have called it point symmetry. Just know that the point about which the graph is rotated, that is the point of symmetry there. Okay, so for example 7, when you have to identify what type of symmetry it is, your answers are either going to be line symmetry or point symmetry. And all you have to do is see if it's a reflection or a rotation. Okay, it's going to be a reflection if you can draw a line down the middle or straight through, okay, and it's the same on both sides. Okay, in this case, the y-axis is the line of symmetry. if I cut this in half and folded this over, it would be the exact same thing, okay, which means this has line symmetry. Okay, if I were to cut this in half, if I reflected this over, it would be here. So that does not have line symmetry. If I tried to cut it this way, it would fold over. That would not work. So let's see if it has point symmetry. There's a couple ways I do this. One way is I usually just pick a point and see if it makes a straight line, because 180 degrees is a straight line. Okay, so if these points make 180 degrees, it has rotational symmetry. Another way you can do this is 180 degrees is the same thing as turning the paper upside down. So if you turn the paper upside down and it's the exact same, okay, then it's going to have point symmetry. Okay, so this one has point symmetry. All right, now the last thing we're going to do today is to prove with algebra whether a function is odd or even or neither. Okay, so in your textbook, they have this key concept box, and I put it right here on our notes. Okay, so the key concept is even and odd functions. All right, this is going to be the most complicated thing we're going to do today, but that really isn't saying much because I feel like today's been pretty light, right? Okay, so when you're determining whether a function is odd or even, the first thing you're going to do is see what kind of symmetry it has. If you have an even function, then it's going to have a line symmetry with respect to the y-axis. Okay, so if it is an even function, it should have line symmetry with respect to the y-axis. And what we're going to do is this algebraic test. Okay, so it says for the algebraic test, for every x in this domain, f of negative x is equal to f of x. So if it is even, I'm going to write that next to it, you have to prove f of negative x equals f of x. Okay, and yes, I want you to write that down because I want it to stand out because we're going to be doing that a few times today. Okay, so if it is an even function, we are going to prove that f of negative x equals f of x. And it's okay that that means absolutely nothing to you right now because I haven't told you anything about it yet. Okay? All right, now if it is odd, if it is an odd function, then it is going to have point symmetry with respect to the origin. Okay, if it's an odd function, it's going to have point symmetry with respect to the origin. And the algebraic test is f of negative x is going to equal negative f of x. Okay, so if it is odd, we have to prove this statement. You have to prove f of negative x equals negative f of x. Okay, and that word prove might scare you a little bit after last year. We are not doing a formal proof, okay? We're going to be using some algebra to prove that. Okay, and the first thing you're going to do is you're going to look at the graph given. And based on that graph, you're going to have an idea of whether it might be even or odd. So according to this graph, you have line symmetry. Okay, so that tells you that you are going to see if it is an even function. Okay, I'm going to write out the steps for you that we're going to use. So if you get stuck later, you can come back here. So to prove with algebra, okay, to prove with algebra, you are going to show that f of negative x equals f of x. You're going to show that f of negative x is equal to f of x. We're going to do that in 2 steps. The first step is we are going to evaluate f of negative x. Okay, we are going to evaluate f of negative x. And then leave some room here and because we're going to write something else. And then what you're going to do is compare f of x and f of negative x. Okay, make sure you have that written down. I went too fast in my earlier class, so if I'm going too fast, just raise your hand and I can give you time. Okay, so in order to understand this, we have to remember how this function notation works. You don't have to write this part down, just pay attention with me, okay? So if I told you that f of x was equal to x squared plus 1, and I told you to find f of 1, would some of you remember how to do that? Yeah, you just plug the 1 in for x, right? So if it's f of 1, instead of x squared plus 1, see how x is being 1 is being substituted for x there? You would just plug that in, and then you would evaluate. So 1 squared is 1, 1 plus 1 is 2. Okay, that's with numbers. This is going to be with variables, so sometimes that throws people off a little bit. If I were to find f of negative x, I would do something similar. So I'd have x squared plus 1, but instead of x, I would plug in negative x. Okay, I want you to think about what negative x squared is. Technically, it's not x. Yeah, it'd be x squared, right? Okay, because if you have this, it's negative x times negative x. And then a negative times a negative is going to be a positive, so it's positive x squared. Okay, so you're evaluating this conceptually, which I know is a little bit different. Okay, so when you are finding this, we're just going to write ourselves a little note about what that means. When you're evaluating this, what that means is you are going to plug in negative x, and then you're going to simplify. Okay, and I know simplify means like 50 different things in that. In this case, it means you are going to be using your exponential rule. Okay, so you plug in negative x, and then you use the exponential rule. So if you're multiplying 2 negatives together, it's positive. Okay, if you have an odd number, something else is going to happen. Okay, and then our second step is to compare. So you're comparing f of x and f of negative x. So f of negative x, for my example, was x squared plus 1. I'm going to compare it to f of x. All we have to do is ask ourselves if they're equal. So are they equal? Yeah, they're the same. Okay, so okay, if they are the same, then we know that it's going to be even. Okay, if they're not the same, then it's just not even. If they are the same, even. If your answer is no, then it's not even, and then we would try to see if it's odd. Okay, now the process to see if it's odd is a little bit different. You're going to start the same way where you're looking at the graph and you're saying, all right, is this line symmetry or point symmetry? If you look at the graph and it's point symmetry, then this is how you're going to prove with algebra. Okay, so to prove with algebra, with your odd values, your first step is the same. You are going to evaluate f of negative x. So we're not going to write this part, and again, it's the same thing. Evaluate f of negative x, so we're plugging in negative x and we're simplifying. Now this one has 3 steps because our second step, when you are proving this with algebra, you are trying to prove, let's look here, you are trying to prove that f of negative x is equal to negative f of x. So you're evaluating f of negative x. Now you have to find negative f of x. So you also have to evaluate that value. Okay, so you have to evaluate negative f of x. So let's talk about how that's different than this one. If you are doing negative f of x, where the negative is on the outside, the negative is on the outside, and you put the function in parentheses. Again, you don't have to write this one down. I'm just using this as an example. And if you have the negative on the outside, what do we have to do with that? We're going to have to distribute. So yeah, the first one becomes negative. Okay, and then our last step again is to compare. So once you do that, if you're comparing this to the original, are they the same or are they not the same? Is this the same as f of x? Or is this the same as really f of negative x? No, and if they're not the same, in this case, it would mean it's not odd. And we know it's not odd because we just proved it was even. Okay, so your third step is going to be to compare, but you're not comparing to f of x. You're comparing steps 1 and 2. Okay, so you're looking at what you got in step 1, you're looking at what you got in step 2, those results, you're comparing them, and then you're just asking yourself, okay, are they the same? And if they are the same, they are what? In this case, they would be odd. Okay, now, there are going to be cases where it's not odd and it's not even. There'll never be a case where it's both. It's either even, odd, or neither. Okay, it can never be both. So we're just going to write just a little note down. Okay, functions can be neither even nor odd. Okay, so that does happen sometimes. If you check both of these and your answer is no, that's when it's neither. Okay, so in some cases you have to do your 2 checks to see if it is neither. Okay? All right, so we're going to practice this. For example 8, it says determine whether it's even, odd, or neither. Confirm algebraically. And we're going to put a cloud around that because this is the key direction here that's telling you you have to write that out. Okay, you have to do that step on your homework if you want credit for it. And it is going to be something you will have on your quiz. It'll be next week, and I'll put the date up there. Okay, so if it is odd or even, describe the symmetry. Okay, and that is going to be pretty simple because anytime it is even, the symmetry is line symmetry with respect to the y-axis, and then if it is odd, it is point symmetry with respect to the origin. Okay, so the first thing we're going to do is determine whether we want to check if it's even or odd. So what we can do is look at the graph. Does this look like line symmetry or point symmetry? Okay, so this looks like line symmetry. Okay, so check if even. Okay, when you're confirming algebraically, you have to make sure you show each step. Again, this is another one of my notes. This means that's something I'll be checking for on your quiz when you do that. Okay, so our check with algebra. If I'm checking for even, I'm using my notes, I'm looking at my step. The first thing says to evaluate f of negative x. Okay, so step 1, we're going to evaluate this. Okay, the function is right here. So when you're plugging that in, I would do 3, and then instead of x, I would put parentheses squared plus 5. We'll find out. Okay, so if it's f of negative x, what am I going to plug into the parentheses? Negative x, so can you guys plug that in? And then let's see if we can simplify. So we're going to plug it in, and then we're going to see if we can simplify. Okay, so when you're simplifying, you're just thinking to yourself, okay, if I have negative x squared, a negative times a negative, that's going to be positive, so this becomes 3x squared plus 5. Okay, and again, that comes from negative x times negative x is x squared. X squared times 3 is 3x squared. The plus 5 stays the same. Okay, and then your second step is to compare. Okay, so when you compare, you're asking yourself, does f of x equal f of negative x? Okay, so let's check. This is f of x. Are these two equal? Yeah, 3x squared plus 5 is 3x squared plus 5. So what do I get from that? What does that mean? Yep, it means that it's even. And then it says we also have to describe the symmetry. Okay, so if it's even, you have line symmetry. And you can either say with respect to, or you can say about the y-axis. Last year, would you guys say like it rotates about an axis or a point? Okay. That's why I put the about in there, even though I can see this book says with respect to. Either one of those are fine. Okay, so it's even and it's line symmetry about the y-axis or with respect to the y-axis. All right, for number 20, I'm going to start in a similar way. So I'm going to look here. I'm going to ask myself if I think that's line symmetry or point symmetry. Okay, and if I cut it in half, I know that it's not going to be a reflection. So I'm going to see if it's odd. So it's point symmetry. So I'm asking myself, is it odd? That is the way that you prove it. And it says right here, you got to confirm it without. No, because I'm not a brain surgeon. I can't look inside there and see that. Okay, so the first thing we're going to do here, if it's odd, is we're going to evaluate f of negative x. Okay, so here is your f of x. I want you guys to try to plug this in. So let's see if we can plug that in and do some simplifying. And feel free to try to simplify it on your own. I know a lot of you do. All of our first steps should look the same. So everybody's first step should have the parentheses with the substitution. Okay, so no matter what, your first step is always going to be that substitution. Does not have to be in two different colors like I'm going to show you. Okay, but this is exactly what your first step should look like. Negative x cubed minus 5 times negative x. Okay, so everybody's first step is going to look the same. Now, some of you might do this in 2 steps. Some of you might do this in 3 steps. Either one is fine. Now, when we were doing negative x squared before, we talked about how that's negative x times negative x. So if you have negative x cubed, that's negative x times negative x times negative x. What's that going to be? Not just negative x to the third, yep. So this becomes negative x to the third, but what's still hanging out outside? Another negative. Okay, and then here we have negative 5 times negative x. What's that going to be? Positive 5x. Okay, so you guys can write this in this step, and then a negative 1 times, really that's a negative 1, is going to be positive, so it would be 1x cubed plus 5x. Okay, that is what this is going to equal. And I'm going to box that in because we're going to compare that to what we get in step 2. Okay, some of you are going to do this part in your head, and I'm okay if you go from here to here, okay, for this, but you have to have this first step. Okay, that first step needs to be the same, so I know that you know how to plug it in. Okay, and then my second step is negative f of x. So it's negative, and then in parentheses, we have this, and I want you to go ahead and try to do the second step. We got it. Positive self-talk, we got it. All right, and then when you distribute, negative times a negative is going to be positive x cubed. Negative times negative is going to be positive. And we are comparing steps 1 and 2. Okay, so 1 and 2, are those the same? Are these equal? Same? Yes. So then our answer is going to be that it's odd. Okay, and then we just have to say that this is point symmetry. And if you want to abbreviate like I am, that is fine. Point symmetry, and this time it's about the origin. Okay, anytime it's odd, it'll be point symmetry. About the origin, and anytime you have even, it will be line symmetry about the y-axis. Okay, your homework for 1.2 is doing Google Classroom. So I know some of you aren't used to doing that. If you need to set an alarm when you get out of here to make sure that gets turned in, you can do that.